Welcome to Lesson 8.6, Rational Equations. In this lesson, we get to solve for x with equations that involve fractions. All of our answers now are going to be in the form of x equals something. In the last two lessons, we were simplifying rational expressions. Now we're solving. A rational equation is one that contains at least one rational expression. An equation that contains at least one fraction. The best thing to do when you've got a fraction and denominators is just to get rid of those denominators. Let's get rid of them, make them nice, simple equations. To do that, we're going to multiply all the numerators by the common denominator. So we'll come up with the common denominator, multiply every term by that common denominator, simplify, and solve for x. So let's see how this will work with our first example. X over 3 plus x over 2 is equal to 10. The first thing I want to do is to make everything involved into a fraction so that I can look at all denominators and come up with that common denominator. One thing you can do when numbers are involved is just multiply all the numbers together. My common denominator would be 3 times 2 times 1, which is 6. 6 involves all three numbers. I want to get rid of that denominator. And to do that, multiply all numerators by 6. And when I say all, I mean even the one that's on the right. So I take 6, x over 3 plus 6 times x over 2 equals 6 times 10. Don't forget this last one. What you do to one side of the equation, you have to do to the other. Now I can cancel. 6 divided by 3 gives me 2x. 6 divided by 2 gives me 3x. And 6 times 10 is 60. What I've done is I've taken an equation involving denominators and just got rid of those denominators. 2 plus 3 gives me 5. 5x equals 60. Divide both sides by 5. X is equal to 12. Let's take a quick check and make sure x really does equal 12. Coming back to my original problem, 12 over 3 plus 12 over 2. 12 divided by 3 is 4. 12 divided by 2 is 6. And 4 plus 6 is 10. Always come back and double check your work to make sure it's accurate. All right, let's look at another one that's got a little more involved. What is the common denominator? In the last example, we just took all those numbers and multiplied them together. We can do that here as well. I can take the binomial x minus 1 times x minus 2. That is my common denominator. Don't actually FOIL it out, just write the two together. Now I want to multiply all the numerators by this common denominator. When I multiply, keeping my binomials in parentheses, I can then reduce any binomials that are exactly the same. So my x minus 1 in the denominator is canceled with the 1 in the numerator. The x minus 2 in the denominator is canceled with the x minus 2 in the numerator. Again, I can only do this because I'm doing it to both the left and the right side of the equation. When we're simplifying expressions, like in the previous lessons, we couldn't do this because there was no equal sign involved. As long as it's an equation, You can multiply anything you want into the equation. So now I'm left with 4 times x minus 2. Distribute. So it's 4x minus 8. And 5 times x minus 1. Distribute. 5x minus 5. And solve your equation. I'm going to subtract the 4x to both sides. I'm going to add the 5 to both sides. 4 minus 4 cancels. Negative 8 plus 5 is negative 3. 5 minus 4 cancels. Sorry, reduces to x, and then 5 and 5 cancels. So x is equal to negative 3. Let's go back to the original problem and double check our work. I have 4 over. Remember, x was negative 3. So negative 3 minus 1. That gives me 4 over negative 4, which is negative 1. Let's see if the right side is the same. 5 over negative 3 minus 2. 5 over negative 5, which is also negative 1. So it checks out. Okay, let's do one more example together. This is about as complicated as it's going to get. And we're going to follow the same steps as we did before. I just have to add one extra thing into it. That is, I need to factor. I can see a GCF in the first fraction. I see difference of squares in the second fraction. Let's go ahead and factor. So I pulled out the 2, leaving me with x plus 1 as my binomial. I took the difference of squares. The square root of 1 is 1. Make 1 a minus and one of the groups a plus. And then on the right side, x minus 1 could not factor. Now I need to come up with my common denominator. Just like we did in the past 2 examples, I'm going to just multiply all those denominators together. But anything that's a repeat, I only need to include once. So I have the 2. That's part of the common denominator. Here's x plus 1. I've got it twice. I don't need to include it. I've already written it in the common denominator section. I've got x minus 1. But again, I only need to write it one time. So when I see it here, it's already in that common denominator section. So now let's rewrite the problem and multiply all 3 numerators by this common denominator. Okay, I've rewritten my problem to kind of give myself a little bit of extra room. I'm going to take this common denominator of 2, x plus 1, x minus 1, and I'm going to multiply it to each of the 3 fractions, only into their numerator. So it would be 2, x plus 1 times x minus 1 times 5, and on the right-hand side. Now I can go through and reduce. That is an R, sort of. All right, I see a 2 in my first fraction, denominator and numerator. X plus 1, denominator, numerator. That leaves my first fraction with 1 times x minus 1. Distribute, it's just x minus 1. Do the same thing now with the second fraction. X minus 1 cancels, top and bottom. So does the x plus 1, leaving me with 2 times 5. So plus 10. And in my right-hand side, the x minus 1 cancels. leaving me with 2 times 1, which is just 2, and then distribute. 2x plus 2. Now I can combine like terms and solve my equation. I have negative 1 plus 10, so x plus 9 is equal to 2x plus 2. Let's subtract the x, subtract the 2, x and x cancel, 9 minus 2 is 7, 2 minus 1 is x, and the 2's cancel. My solution is x equals 7. Okay. And let's go ahead and go back and check the answer. This is all of my work in checking the solution. You can go back through it if you want to. I just substituted my x equals 7 into my fractions and solved down. And I finally got 8 over 48 on the left, which is equal to 1 over 6. So my solution of x equals 7 was correct. All right, I have one problem now for you to try completely on your own. Push pause as you work through it, and then resume play to check your answer. All right, to walk you through this problem, or how I solved it, I found the common denominator, as we've done before, 5x. I multiplied each numerator by that 5x. I reduced everything that I could, so the 5 and 5 canceled, leaving me with 3x squared. The x's canceled, leaving me with 4 times 5, which is 20. And the 5's canceled. When I distributed the x, there's the 4x squared times x, or plus x. So I've noticed that it's got both x squared, x, and a number. This is going to end up being a trinomial. With a trinomial, I need to set it equal to 0. You want your x squared to be a positive number, so I subtracted the 3x to the right side and subtracted the 20 over. That gave me x squared plus x minus 20. You'll know you need to do this if you've got x squared, x, and a number with no variable, a constant, in your equation. It's a trinomial. I factored using the a times c method. A is a 1, so I took 1 times negative 20. What multiplies to give me negative 20 and adds to give me the positive 1 here on the b side. So that was positive 5 times negative 4. Positive 5 plus negative 4 gives me positive 1. A is a 1, so when I divide them each by 1, nothing changes. So it was x plus 5 and x minus 4. Set each one equal to 0, giving me that x is equal to negative 5. Add the 4 over, and it gives me x is equal to 4. I then went back to the original problem to check my answer. And I'll show you that check here. You can go and walk yourself through it if you'd like to. But my final answer, x equals negative 5 and x equals positive 4. So I hope you enjoy solving equations with fractions. They're not too scary. Just get rid of the denominator and then solve your equation.